Hello everyone. Today inshallah we will continue with the integration. Today's mission is to go through mainly the antiderivative and substitution, but also I will try to finish with you the ideas of direct integration, going through partial fraction. The main issue of today, I need to finish the partial fraction, and also I will go through the integration by parts. Today is really very important. We will finish a lot of topics and we will try to solve as much problems as possible. What I really do need from you is to try to resolve these problems in home with your pen and with a pen and paper. Try to do this. This is really essential, especially in the part of antiderivative or integration. It's not difficult, but it needs training and it needs a good understanding. Today, inshallah, we started already direct antiderivatives in the previous week. So today I will continue with direct antiderivatives and hopefully we will go to substitutions. If not, I will delay it to the next week, inshallah. As I told you, our course notes and references, you will find them on Moodle. And the recorded lectures, you will find them on YouTube, so there is no problem whatsoever. The agenda of today, definition of antiderivative, direct antiderivatives, antiderivatives by parts, and antiderivatives by substitution. Inshallah, we will be able to do this today. Before we start, I want you to remember that this is the symbolization of integration, the function that really exists in between the sign of integration and the variable that we are going to integrate with respect to is called the integrand. This is the integrand of this function, and of course, once we integrate, we will regain the main shape of the function plus the constant of integration because we are dealing with the indefinite integration. In the previous session, I've also introduced the most usable laws in integration, for direct integration. I want you to remember that number one, if I want to integrate f dash x dot f of x to the power of n with respect to the x, the integration in this case is direct, but under one condition, that the function inside this bracket already its derivative exists in the outside. So that's a very important condition. Usually, Omar, I call it a condition in order to apply this law. So if I have f of x to the power of n times f dash x, then the integration will be really very simple. It's going to be f of x to the power of n plus 1 divided by n plus 1 plus a constant. This is very important law, one of the most important laws in integration. Remark that this is valid for every value of n except n doesn't equal to -1. So for every value of the power, even if it is radicals, fractions, negative powers, whatever, it will be applied, except when n is equal to -1. So if you have a bracket to the power of -1, this is not going to be applicable. So what's going to be the case if n is equal to -1? If n is equal to -1, this is going to be the shape of your function, f of x, dx, that as I told you, you still have f dash of x. And that's a condition for integration. This is a condition for integration. That's the condition. That the derivative of the denominator really exists on the numerator. If this exists, then the result is really very simple. It's gonna be ln for f of x, okay, absolute, plus a constant. This is the form of integration. So once the condition really exists, then the result will be ln f of x plus c. Number 3, from the direct relation, an integration for e to the power of f of x dx, which is the form of an exponential function, also times f dash of x. Remark that the derivative of the power already exists. That's a condition. So once this condition is approved, or this condition exists, then the result will be e to the power of f of x plus a constant. And there is a general case about the exponential function. If you have an integration for f dash of x, but this time to the power of af of x with respect to the x. In this case, you have a, not e. So it's like 2 to the power of f of x, 10 to the power of f of x. If this happens, also with the condition that f of x derivative already exists, then the integration will be a to the power of f of x divided by ln of a plus a constant, as you can see. Those are the main the main laws that we are going to use. This is really very important. I need to focus with them in order to solve any problem. So once more, review the previous session, then let's try to solve these problems. If you look to the first problem, which is 6 divided by 3x plus 1, start to look to this problem and each of these laws and see which one of them can be applied. If I am in your shoe, then I will remark that I want to integrate, which is 6 divided by, the denominator is 3x plus 1, and the integration with respect to the x. So the first thing that you should think about is to be sure that the derivative of the denominator already exists. So I am going to check. What's the derivative of the denominator? What's the derivative of 3x plus 1? It is simply 3. Do you have 3 on the denominator? Can you see 3 on the denominator? Yes, of course I can. Okay, it is really very simple. I will multiply by 3, okay, and divide on 3. This is difficult? No. Okay, so all I need to see is 3. Now try to adjust this problem with the nearest one in those cases. I believe this is really very tempting. So I will try to put it on this form. Simply, I can take 6 outside. So it's going to be 6 over 3, which is going to come up to 2. That's the integration of a 3 with respect to the x divided by 3x plus 1. As you can see, the derivative of the denominator, which is 3, already exists. Once it is already exists, then this rule can be applied. So simply the result will be equal to 2 ln the denominator, which is 3x plus 1, and don't forget to add the constant of integration. So it's really very simple. Okay, if I look to the second problem, which is, once you look at it, which is x, the root of x squared plus 1 with respect to the x. Also, I will look to this problem, and I have the various laws that I can apply in order to integrate. Do you have questions? Okay, so this is for the first problem. Let's see how we deal with the second one. The second one is very, very simple, which is the integration of x times the root of x squared plus 1. I can put it on this form, x squared plus 1 to the power of half with respect to the x. Now I will start looking to the laws that I already remember for the direct integration. If you look to this case, with all of these cases, it's not, there is no denominator, it's not, of course, an exponential function. So this looks really very tempting. Okay, let's check. The derivative of what's inside the bracket, the derivative of f of x is 2x. I can see this at the beginning or beside this bracket. I can build or find this value. Usually, Omar, I can't multiply in a variable and divide on this variable. But I can simply multiply in a constant and divide on this constant. So it's very, very simple. All I have to do is to multiply by 2 and divide on 1 over 2. Of course, the constant can take out the integration sign. Now the condition really exists. As you can see, f of x to the power of n times f dash x. If this happens, that's the condition. If this is happening, then the result will be, all I have to do is to put it on the final form. I is going to equal to, the constant will remain the constant. I will add 1 on the power, so it's going to be 3 over 2. And then I will divide on the new power, plus a constant. What's inside the bracket? We are safe from it, since the integration already exists outside. So it's an x squared plus 1. So simply, it's really very simple, as you can see. All I need at the time being is just a simple adjustment for the constant. So which means I is going to equal to 1/3 of x squared plus 1 to the power of 3 over 2 plus a constant, as you can see. Remarking that if it is a multiple choice problem, it's going to be really very simple, because he will give you the integration and then he will give you more than one alternative to choose the correct answer. The main issue is you have to free your mind about the final shape and about the constants, how to deal with them. This is really very important. Okay, let's try to solve the problem number Q. Any problem? I think it's really very simple. Okay, let's go through the next problem, which is I want to integrate, and also please try to look at it and decide which law are you going to use. I want to integrate 4 to the power of 1 minus x with respect to the x. What law can work with these ones? Number 1, number 2. Number 1, I don't have a function multiplied and it's a derivative. Number 2, I don't have a denominator. Number 3, it is related to exponential functions, but the base is e. Number 4, it is for any exponential function. Stop. I think this is really very good. It is an exponential function with the base not equal to e. So all I have to do is to check that the derivative of the power, let's do it once more. The derivative of 1 minus x, which is going to be -1. Do we have -1 in this problem? I can generate it exactly like the previous one. How to find the -1, Omar? All I have to do is to multiply by -1. Then I will divide on -1. Now I have the derivative. So the main function really exists, which is an exponential function, and the derivative of the power really exists. If this happens, then this is the result. So simply, I can say that I equal to 1 over -1, it's a negative sign. Okay? Then it's going to be the exponential function, which is 4 to the power of 1 minus x, divided by ln, the base of this exponential function, which is ln 4, plus a constant. That's the integration. So, as you can see, the antiderivative with the direct methods or with the direct rules, it's really very simple. All you have to do is to first memorize the laws. Number 2, free your mind. Number 3, start to apply the law as it should be with the condition, then your answer will be guaranteed. Let's look to problem number R, which is really close, so very close to this one. Let's look to this problem. Okay, so any questions in this problem? Okay, very good. Let's do the last problem in this slide. The last problem states that I want to integrate, as you can see, 5 times e to the power of root of an x dx, and it is divided by a root of an x. Okay. No, I think this one may work. No, of course. So I will try to check this one. Try to rearrange your problem. So I think it can be put easily on this form. This is the 5. That's the integration. This is 1 over root of x times e to the power of x to the power of half. And this is d dx. All I need to check is the derivative of the power. So once more, it's an exponential function The base is e, so all I need to check is the existence of the derivative of the power. The derivative of x to the power of half. Any ideas how it's going to be? X to the power of half? Huh? It's going to be a half x to the power of negative half. It is already here, the critical part, which is x, 1 over root x, of course, Mr. Omar. This value is the integration of x to the power of negative 1 over 2 times e to the power of x to the power of half vdx, and this is your 5. But the missing part is simply 1 over 2. So all I have to do is very simple. Multiplying by 1 over 2, and outside I will multiply by 2. So I think now the condition is already exists. The derivative of the power already exists, which is half x to the power of negative half. Now the integration is very simple. I will equal to 2 times 5, which is 10, times e to the power of root of x plus a constant. Okay? So it is just a simple application of the laws. But first of all, you have to memorize your laws really very carefully. Okay? Those problems are just an introduction. There is tons of problems that you can solve. The main issue is to remember the cases. I have f of x to the power of n times f dash x. All I have to do is to add on the power 1 and divide on the new power. This is going to work with you perfectly, but of course avoid n, or it doesn't work when n is equal to negative 1. If n is equal to negative 1, I will use the logarithmic form. If I have exponential functions, they are really easy on the eye to catch, okay, if you have an exponential functions. So once more, let's see on the coming slide. So I want you to remember these laws, okay? I will have to, let me see, for the next slide. Okay, I will have to eliminate to just erase it. If you look to this slide, we don't deal much with the logarithmic, with the trigonometric functions, but just to be with you, I've shared this PDF with you all, I believe 2 days or 3 days ago. If you remark, that's the integration of a sine of x. Integration of sine of x, it's negative cosine of x. Integration of cosine of x, it's sine x. The integration of sec squared, it's going to be 10 of x. The integration of cosec squared, it's a negative cot of x. The integration of sec dot tan of x is going to be sec of x. The integration of cosec times cot is going to be negative cosec of x. Those, or this slide, it's just for your knowledge. You have to keep it with you down the road. If you need it, you can find the integrations. Those all are direct integrations. This is for the anti-trigonometric functions, dx over root of 1 minus x squared. It's going to be anti-sine of x, or arc sine x, or sine minus 1 of x. And the other sisters and the brothers for this value already exist also. You have the hypergeometric functions, which are the sine of x, cosine of x, tangent, and so on, also for you, because to keep it here. If I look to the next slide, this slide summarizes that if you need to integrate, you have to be sure that the derivative of the argument already exists. And actually, this is what we were doing previously. So, for example, okay, not on a trigonometric, for example, if I have e to the power of f of x, you have to have the derivative of the function in order to integrate. And then the integration will be e to the power of f of x plus c, which is exactly like this one. If I want to integrate cosine f of x, then you should have f dash of x in front of this integration. That's a condition for integration. And if this happens, I will, I'm not going to look to the function or to the argument and its derivative. I will focus only with cosine, which integration will be a sine of the argument plus a constant. This is what is stated in this slide. how to integrate a little bit complicated trigonometric functions. Also, it is not direct, or I'm sorry, it's not so important for us, but I wanted to be in your mind. So once more, if I want to integrate, let's look at some of these problems. I will look to the simple ones only. If I want to integrate cosine 2 over x with respect to dx, if I want to do this, all I have to do is just to check the existence of the argument, the derivative of the argument. As you can see, the argument here is 2x. So the derivative of this function is 2. Do I have 2 times cosine? No. But I can do it. How to do it, Omar? All I have to do is to multiply by 2 and then divide on 2. And this manner, I didn't do anything. The number that I multiplied, then I divided on it. So they will eat each other. But I already found the condition or the law. Then simply I is going to be half integrate cosine, which is going to be sine over 2x. Don't forget to add the constant of integration. This is how to integrate trigonometric functions. Also, once more to be sure that it is already in your mind, if I want to integrate, for example, x dot a sine of an x squared dx, it's exactly the same. Once more, Mr. Safe, I will try to block to the argument, which is x squared. The derivative of x squared is 2 over x. Do I have 2x? No, but I can have it. How to have it? Okay, simply, I will multiply by 2, divide on 2. The condition is satisfied. The condition is perfect. Now I have the derivative of the argument. So the integration will be half of, I will integrate sine of x. The integration of a sine, it is negative cosine. The argument, which is x squared, plus a constant, as you can see. The spirit of integration really exists. It's all about the existence of f of x and the derivative of the argument. If they exist, then you can integrate simply with no problem whatsoever. Okay, let me go further for more problems and more ideas. Okay. All of this are problems related to what I'm telling you about the trigonometric function. So the integration for sine x is going to be negative cosine of x. The integration of cosine x is going to be sine x. The integration of sec x times tan x, it's going to be it's going to be sec of x. If I have tan of x dot cosine of x, I know some manipulations of the trigonometric functions. So for this problem, it's very, very simple. It is the integration of cosine of x dx times tan, which is simply, you are correct, it is sine of x over cosine of x. I can cancel these two parties together, and then I will have sine of x dx, and the integration at this time is going to be a negative of a cosine x plus a constant, as you can see. It's really very simple and easy to be done. Those are the main laws, as you can see, that we can do, use for trigonometric functions. I'm not going to lose more time in this part. I will skip it, and you have the PDF already with you. I will start to talk about the rational functions or the rational integrands, and this is really very important. The treatment of rational number of rational functions. A rational function contains a numerator and a denominator. There is conditions for this. Okay. Some rational functions have direct or almost direct antiderivatives, like the one that we solved earlier. You have the denominator derivative really exists on the denominator, so it's really a matter of just a brief adjustment, multiplying in a constant, dividing on a constant, or something like this. Okay? Or our first attempt at finding a rational antiderivative should be to check if it has a direct or almost direct form. Okay? Like the problems that we have previously. Okay, let's look to this problem. This problem is really very simple. You have a numerator and you have a denominator. Most of them are polynomials. The rules are in my mind. The rules are in my mind. The first thing that I'm going to look at is the denominator. Once I have a denominator, the degree of the denominator, it is of degree, second degree. Am I right? So I need to check if the derivative of this denominator already exists on the numerator. Okay? And the remark says that the general power of the denominator is positive 1. Am I right? Okay? Once the denominator power is positive 1, in this case I can't use the law which contains f of x to the power of n, but I can instead use this formula. If you remember, if I want to integrate f of x and have f dash x on the denominator, if this happens, then the answer is then f of x plus a constant. That's the result of your integration. So all I have to do now is to be sure that the derivative of the denominator is already exists. The derivative of this denominator, Mr. Muhammad just came, the derivative of the denominator is going to be 2x plus 2. Is this possible to find a denominator? Can you find this value on the denominator? Yes, we can. Simply, it is missing 2. So all I have to do, Mr. Safe, is to say that I equal to 1 over 2, this is the integration. I will multiply by 2 the value of x plus 1. And in this case, the derivative of the denominator already exists on the numerator. So once more, the condition now is complete. The derivative of the denominator, it exists on the denominator. So the integration will be very, very simple. I will be a half ln absolute the denominator, which is x squared plus a 2 over x plus a c. Of course, the ideas here are limited. You have plenty of ideas, okay? But you have to check the major thing, that if you have a numerator and a denominator, if it is on the direct form, as you can see, okay? Okay, very good. Can you please try to see if it is possible to solve this problem? Can you solve this problem? Once more. Once more. What's the derivative of the denominator? Let's do the derivative of the denominator. What's the derivative of the denominator? The derivative of 3 is 0. Then I have 4e of x. The derivative is going to be 4 times e to the power of x. Did this exist on the denominator?
4 no, x.
Missing 4. So it's very, very simple. Once more, I will have to multiply in 4, then divide on 1 over 4. And then I will be, the condition already exists at the time being, I will be a quarter of ln 4, 3 plus 4 of e to the power of x plus a constant. We can spend the whole day playing with functions like this. Just looking at the problem, okay, guessing if the derivative of the denominator really exists on the denominator. If it exists according to the laws that I gave you in the previous session or at the beginning of our lecture today, then it's going to be a direct integration rule and it's going to be very, very simple. The problems will start to appear once you have improper fraction. And the coming slides will make you know how to deal with these fractions. So this problem, as you saw, it's very, very simple. Okay, compute the following rational antiderivatives on an interval of the domain of the antiderivative. I need to integrate x to the power of 5 minus 4 over x to the power of 5. In this case, usually in integration, the degree of the denominator should be less than the degree of the denominator. What if they are equal to each other? Like this case, try to find the solution, Mr. Omar. Try to distribute the numerator on the denominator. This problem can be really very easily solved by just distributing the common denominator. So I will consider it like x to the power of 5 divided by x to the power of 5 minus 4 over x to the power of 5 with respect to the x. Any problem? Okay, so the second step, Mr. Safe, I will equal to 1, then negative 4 divided by x to the power of 5 with respect to the x. Or instead of writing this in this form, I can simply rewrite it on this form. Negative of 4 times x to the power of negative 5 with respect to the x. Start integrating. Integrate 1, which is x. For this function, it's an x to a power. So all I have to do is to add 1 on the existing power and then divide on the new power. So simply, it's going to be a negative 4 times x. Add 1 on the power, which is going to be negative 4, divided by negative 4, plus a constant of integration, which means I will equal to x. Those guys will eat each other, plus x to the power of negative 4 plus a constant, as you can see. The integration is very, very simple. But you will have to, first of all, review the previous lecture, because some of the previous lecture contains the simple integration like x to the power of 2, 1 over x, e to the power of x, something like this, with the main laws. Also, Mr. Safe, if this idea didn't hit your mind, I can do it in another way. I can, first of all, this is an improper fraction because the grade of the numerator is greater than the grade of the denominator. So I will need to put it on a proper fraction first, which means there is a value, okay, beside this fraction. So how to do it? I will use long division, which is very, very simple. All I have to do is to write my numerator on this side, which is x to the power of 5, and write the denominator on this side, which is x power 5 minus 4. I'm sorry, this is x minus 4, and this is x to the power of 5. Let's do long division. Mr. Safe, I know you love it. Okay? I will try to divide x to the power of 5 on x to the power of 5. The result will be 1. Then multiply. Multiply 1 times x to the power of 5 is going to be. Then I will add negative sign and they get the addition of this value. X power 5 minus x power 5, it will disappear. You will have just only negative 4. Since this number is less degree than x to the power of 5, then instead of dealing with this integrand, I can deal with 1, which is the quotient, plus the remainder, which is negative 4, over x to the power of 5 with respect to the x. This is exactly like what we have in this part. Am I right?
Yeah.
Okay? Now I can do the rest of the problem. So either you are lucky enough to have one of the manipulation by distributing the denominator on the denominator, or do a couple of games. I will show you these maneuvers in coming problems, or use the general method is to divide the denominator on the denominator, get a quotient, and then the remainder term I will deal with it according to the situation. So this is really very important. As I told you, you will have to resolve these problems more than once. This is really major. Okay, so once more, get back to this case. If it is proper, which means the degree of the numerator is less than the denominator, this is going to be solved using the partial fractions. Like if it is improper fraction, which means the degree of the numerator is greater than or equal to the degree of the denominator. In this case, I will use long division, as you saw. Or try to manipulate a little bit if you are lucky enough, okay, to do the manipulation. I will show you examples. So once more, in functions or in fractions, I have two cases. The case of a proper fraction, what's the proper fraction, Mr. Muhammad? The degree of the denominator is less than the degree of the denominator. So it's a first degree on the second degree on first degree, and so on. Of course, the degree is the power of x. Okay, it is the power of x. معايا مستر سيف؟ Okay. أنا شايف إنك stable النهارده. طبعا that's an explanation of the long division exactly as we did previously. So I skip this one. Let's solve this problem. How to solve this problem? Any ideas? Is it proper or improper? It's an improper because the grade or the degree of the denominator is greater than the degree of the denominator. I can use a lot of things. I can manipulate if I can. So it's really very simple. Or what I mean, there is manipulation if the integrand help you to do something like this. Like, for example, yes, you are correct, Mr. Saif. I can add, this is going to be x squared divided by x plus 4. Yes, you are correct, of course. I will add negative 16 and add positive 16. You are correct. If I add negative 16 and the positive 16 in specific, in this case, I can, for this problem, I can separate it like this. It's gonna be x squared minus 16 over x plus 4. Then plus just only 16 over x plus 4 with respect to the x. So all I had to do is to add 16 and negative 16. Of course, Omar, you know why I added especially 16 and negative 16. Because adding these numbers, as Mr. Sif was telling us, this is gonna be, okay, a perfect square. So it's gonna be simply the root of x minus, the x minus 4 times x plus 4, and all of them divided by x plus 4 plus a 16 over x plus 4 with respect to the x. And in this case, now you have a solution for the denominator. So they will cancel each other. And we are